Welcome back. Today we're going to talk about diamonds and why they're worthless on your chubby little fingers. Diamonds are one of the hardest materials known to man. Composed only of carbon, this material is much stronger than, let's say, charcoal, or at least your parents' relationship. The four sigma bonds holding the lattice in place never fail to encourage strength and dominance by consistently going to the gym and never skipping leg day. While your diamond engagement ring may be good for scratching up your ex's car because of this increased strength, diamonds have a much larger range of uses. First, let's begin with where are diamonds found? Where do they come from? Natural diamonds are found through mining all over the world, and while they tend to be displayed in that really nice, aesthetic looking geometric shape that we all love and desire, they come out of the earth looking like this really weird f***ed up bullshit. And yes, this is the biggest diamond ever found, and believe it or not, we still say there's a shortage. No conspiracy there. But let's say you can't mine for diamond. You don't have millions and billions of dollars, and you don't have hundreds and thousands of people to scour the earth's surface for these shiny precious stones. So you decide to pursue another method. This one involves taking carbon and turning it into diamond. There's actually two ways to do this. One involves taking carbon and applying massive amounts of heat and pressure until out plops a diamond. You might be thinking, wow, that sounds simple as hell. Let me take a cigarette lighter and squish this piece of carbon with my hands when it's hot. But if Ronnie Coleman at his prime was not able to apply enough pressure to make diamonds with his bare hands, neither can you. And therefore, this method tends to require a lot of energy to create any sort of viable product. So there's a much easier process to create diamonds. If you were to take methane gas in a closed vessel full of hydrogen gas and then decided to maybe excite the methane with, let's say, an acetylene torch, arc discharge, or maybe even possibly microwave radiation, you could then get carbon to deposit across a substrate on the bottom surface. This is known as chemical vapor deposition, or CVD. And all this really means is we're taking gas and making it become a solid. And as this carbon deposits, it forms bonds with more carbon that's depositing. And eventually, we result in what is known as a diamond lattice. There is this strong, beautiful sigma bonding between these carbons, and that is what makes it diamond rather than something such as graphite. Diamond has sp3 hybridization, meaning that instead of there just being 3 sigmas like in your pencil lead, there are 4 sigmas holding it in place. This sigma bonding allows for fantastic thermal conductivity, and therefore it can always be cool, just like man. In a way, think of this beautiful thermal conductivity like taking a red-hot steel ball and dropping it directly into the ocean. Just as the heat would dissipate into the ocean from the steel ball throughout the water surrounding it, diamonds work in a similar way, but instead of water, it's a sea of carbons and sigma bonds. Time for another drink. With the very high thermal conductivity, diamond can do what many things struggle to do, and that is cool things faster and more efficient than any marriage counselor ever could. You might be wondering, why should you care? Well, you care for the same reason you have 75 fans all across your PC trying to cool your CPU. Because cooling means more efficient computing and less lag on Modern Warfare 2, at least on your end, because the game still f***ing glitches and the servers still suck. While not really implemented directly, there are prototypes of silicon diamond chip which have been made and have shown that diamonds really can ice out your CPU. What was shown and demonstrated is that the sigma bonds of the diamond can spread that heat like nothing else and make sure that it passes it along, across the wide area that it possesses. Diamonds also possess electrical properties. That doesn't mean you can shock yourself with them, but it does mean they may end up in some electronic devices in the future. Diamond, like silicon, is a semiconductor. However, it has a wide band gap. This means that electrons have a large distance to travel from the valence band to the conduction band. Kind of like traversing KSI's forehead. In order to make that journey, you would need a lot of prime energy drink and a lot of Mickey D's. In a similar way, electrons require a lot of energy in order to complete the journey. You may say, why would you want this? In reality, the answer is you don't. Not really for anything you'll ever do, unless you work in the industrial world or you fly fighter planes. The large band gap allows for things like transfer switches to work very efficiently and prevent power failures or surges from blowing it up. Diamond also has been found to be a viable transistor with a little doping. And no, I don't mean we're out here giving diamond a little that good and, let it snort some of that blow. I mean adding phosphorus and boron to the diamond lattice to create electrical junctions, or p-n junctions. This, along with the wide band gap, has shown to be fantastic in high temperature and high power applications, but you honestly will probably never use this for anything. Because you, unlike the government, can't just print diamonds using gas and electricity, so I just say go back to exploring the world and mining just above the bedrock. If you really want more information, please leave a comment, or don't, because I really don't care. Have a great one, and maybe I'll see you again.